This is day 10 of Advent of Cyber 2025, and this challenge is called SOC Alert Triaging, Tinsel Triage. Best Festival Company Security Operations Center was in chaos. Screens flickered, lights flashed, and the sound of alerts echoed through the room like a digital thunderstorm. The elves rushed somewhere between consoles, their faces lit by the glow of red and orange warnings. It was raining alerts, and no one knew where the storm had begun. Whispers spread through the SOC as tension filled the air. Something strange was happening across the cloud environment, and the timing couldn't be worse. As the blizzard of alerts grew heavier, one name surfaced among the worried elves: the evil Easter bunnies. But why now? What were they after this time? The learning objectives for this are to understand the importance of alert triage and prioritization, explore Microsoft Sentinel to review and analyze alerts, and correlate logs to identify real activities and determine alert verdicts. So for this challenge, there is a direct link which we should have access to, and we'll be given credentials to that. So the content deployed scope has changed since the video is recorded. You no longer have to deploy a lab as part of the setup. Rest assured, the questions can still be answered by watching the video. To get started, go to the Azure portal and use one of the username and temporary access password combinations listed below. Bring up Azure portal, and then we'll grab one of these logins. So let's grab this one here, put that in next, and grab the password for it. Okay, that seems to have worked, and we're now connecting to Azure portal. Let's carry on through. So check we have done that. It's raining alerts. Skitty was notified that it's raining alerts. Something unusual is happening within the Azure tenant. The dashboards are lighting up with suspicious activities. Early signs indicate a possible attack from the evil bunnies. The best festival company must act fast to survive this onslaught before it affects the entire season's operations. So before investigating these alerts in Microsoft Sentinel, Skitty must step back and understand what's happening. When alerts start flooding in, jumping straight into each one isn't efficient since not all alerts are equal. Some are noise, others are false positives, and a few may indicate real threats in progress. This is where alert triaging becomes critical. Triaging helps security teams identify which alerts deserve immediate attention, which can be deprioritized, and which can be safely ignored for a moment. The process separates chaos from clarity, allowing analysts like McSkitty's SOC team to focus their time and resources where it truly matters. So let's continue the discussion about alert triaging. In the previous section, we introduced triaging and why it is essential. This time we'll focus on how to approach it, what to prioritize, what to look for, what to do right after an alert. So when multiple alerts appear, analysts should have a consistent method to assess and prioritize them quickly. There are many factors you can consider when triaging, but these are the fundamental ones that should always be part of your process of identifying and evaluating alerts. So, severity level. View the alert severity rating, ranging from informational to critical, and it matters because it indicates the urgency of response and potential business risk. Timestamp and frequency. Identify when the alert was triggered and check for the related activity before and after the time. And this matters as it helps ongoing attacks or patterns of repeated behavior. Attack stage. Determine which stage of the attack lifecycle this alert indicates, whether it's reconnaissance, persistence, or data exfiltration. And this matters because it gives insight into how far the attacker may have progressed and the objective and affected asset. Identify the system, user, or resource involved and assess its importance to operations. Prioritize responses based on the asset's importance and the potential impact of compromise. So basically, severity is how bad it is, time is when it happened, context, where in the attack lifecycle is this attack up to, and the impact, who or what is it affected. So after identifying which alerts deserve further attention, time to dig into the details. Follow these steps to investigate and correlate effectively. So investigate the alert in detail, open the alert and review the entities, event data, and detection logic. Confirm whether the activity represents real malicious behavior. Check related logs. Examine the relevant log sources. Look for patterns or unusual activities that align with the alert. Correlate multiple alerts. Identify other alerts involving the same IP, user, device. Correlation often reveals a broader attack sequence or coordinated activity. Build context and a timeline. Combine timestamps, user actions, and affected assets to reconstruct the sequence of events. This helps determine if the attack is ongoing or has already been contained. Decide on the following action. If there are indicators of compromise, escalate to the incident response team. Investigate further if more evidence or correlation is needed. Close or suppress if the alert is a confirmed false positive, and update detection rules accordingly. Document findings and lessons learned. Keep a clear record of the analysis, decisions, and remediation steps. Proper documentation strengthens SOC processes and supports continuous improvement. With the triage complete and the investigation in motion, Skitty begins piecing together the puzzle. Every alert, log entry, and timestamp brings her closer to uncovering what the evil bunny is up to inside the Azure tenant. It's time to connect the dots and reveal the bigger picture behind the noise. Let's check that. And environment review. So let's go into Azure Portal, go to Microsoft Sentinel. We want to then select Sentinel workspace there, logs, and then go to custom logs. So Law AC 2025, we then go to logs, exit these, we go to the table, and we want to go custom logs and syslogs. Let's click run on that. So after the query, the logs for this environment should be rendered. We don't see anything, but that would be because of the time range, I'm assuming. So let's try the last 7 days, see if that brings anything up. It does. But to be safe, let's increase the range even further, just to make sure we don't miss anything. We've got November 1st, the start date, and that should be good now. Click check on this and go to investigation proper. McSkitty goes triaging. Now that we have learned about triaging, let's move to the fun part, working inside the actual SOC environment of the best festival company hosted in Azure. This is where McSkitty will put her triage skills to the test using Microsoft Sentinel, cloud native SIEM and SOAR platform. Sentinel collects data from various Azure services, applications, and connected sources to detect, investigate, and respond to threats in real time. Through Sentinel, McSkitty can view and manage alerts, analyze incidents, and correlate activities across multiple logs. Provides visibility in what's happening within the Azure tenant and efficiently allows analysts to pivot from one alert to another. In this next part, we'll explore how McSkitty reviews alerts, drills into the evidence, and uses Sentinel's investigation tools to uncover the truth behind the Evil Bunny's attack. So back into Sentinel. So we have this selected. Let's just go threat management and go incidents. And then it wants us to just minimize the cyber, saying in case the alerts do not appear, refresh your browser page, which we are getting that, so we should refresh. And there we go, saying no incidents found, but that's probably up here saying last 24 hours. Change it to the last 30 days, and then more stuff should come up. There we go. Okay, so they want the task images. There are 8 open incidents. So I think it wants us to go to this exact time range. So let's go to custom time range from 10/29/2025 to 12/13. Let's check the dates. Go 12 p.m. and go 12 p.m. and do the same for the top one. Let's select that. Interestingly, they've only got 8. Well, we've got 1,000. I'm not sure what's going on there, but let's continue. There are 8 open incidents, 4 high, 4 medium. Note that these numbers might differ in your lab environment. Since we focus on addressing the most critical threats first, we'll begin with the high severity threats. These represent potential compromise points or privilege escalation activities that could lead to complete host control if left unchecked. To begin the triage, we'll examine one high severity incident in detail, the Linux privilege escalation kernel module insertion. So maybe we can search directly for this. So let's put that in, press enter. Nothing came up. Maybe we need to change that, or maybe we need to remove this and just do that. Okay, we've got one. We'll try to find the exact one they have. So maybe, okay, no, theirs is different. But we will select this, and we can see on the right here, there's events, creation time, entities, and tactics and techniques. So there are 3 events related to the alert. The alert was recently created. This berries on your lab instance. There are 3 entities involved in the alert. The alert is classified as privilege escalation tactic. So that seems to be similar for us, our one. So what we will next do is go view full details for this alert. In the new view, we can see that in addition to the details shown in the summary, we can also view the potential incident timeline and similar incidents. The incident timeline is this one which has come up, and there are similar incidences here. From the view above, you may notice that several alerts point to the same affected entities. This helps us understand the relationship and the possible sequence of events that impact the same host user. When multiple alerts are linked to a single entity, such as the same machine, user, or IP address, it typically indicates that these detections are not isolated incidents, but somewhat different stages of the same intrusion. By analyzing which alerts share the same entities, we can start to trace the attack path from the initial access to privilege escalation and persistence. So for example, if the same VM triggered the following alerts, alert root SSH login from external IP, it suggests that the attacker gained remote access via SSH to the system, initial access. The alert is SUID discovery. The attacker looked for ways to escalate privileges, and if the alert is kernel module insertion, the attacker installed a malicious kernel module for persistence. So at this stage, McSkitty has reviewed the high severity alerts, identified the affected entities, Notice that several detections are linked together. This initial triage allows her to prioritize which incidents need immediate attention and recognize when multiple alerts are actually part of a larger compromise. With this foundational understanding, XKD is ready to move beyond surface level triage and dive deeper into the underlying logs, which will be discussed in the next task. So, how many entities are affected by the Linux Privesk whole kick exploit attempt alert? So I think for that we need to go back to incidents, search specifically for this. So we go to here, search for this, and entities should come up here. You can see there's 10 entities. Enter 10 here and check. That has worked. Now I need to look for the severity of the sudo shadow access. Go here, search for those alerts, and the severity is high. Like that. And how many accounts were added to the sudoers group in this user added to sudo group alert? There's one here, and we see there's a bunch of entities. So let's dig deeper, and we can see 1, 2, 3, 4 accounts. So I assume that means there were 4 accounts added to the sudo group, and that is correct. Now onto diving deeper into the logs. With the initial triage complete, Skiddy now examines the raw evidence behind these alerts. The next task involves diving into the underlying log data within Microsoft Sentinel to validate the alerts and uncover the exact attacker actions that trigger them. By analyzing authentication attempts, command executions, and system changes, Skiddy can begin piecing together the full story of how the attack unfolded. If we go back to the alerts full details view, you can try clicking the events from the evidence section. So let's go back to kernel module insertion. Go here, kernel, and we'll type in kernel module insertion. We will grab this first alert, go to view full details, and once it's loaded up, we go to events, and then we can dig down into the actual events. Select events, and let's look at this very first event, like so. So from this view, we can definitely see the actual name of the kernel module installed in each machine and the time it was installed. Diving deeper into this, we try checking the raw events from a single host through a custom query. To do this, let's change the view into an editable KQL query and find all the events triggered from app02. So up in the top right here, you can switch to KQL mode. That turns it into the actual underlying KQL query, which was running the simple mode. And let's grab this query and paste that in. Although we can see it's got a different date time. So let's copy the date time that we had and put this here. Actually, no, we'll continue to use theirs. I think this is just a normal KQL thing. So if we run that, we'll get the exact event for app02. That seems to have worked. So yeah, a quick look in here. We can see commands ran. So copy shadow.back to cron tab was ran. Basically ran as a cron job maybe. We can see here, copy shadow to shadow.back. After executing the query, it can be seen that multiple potentially suspicious events occurred around the installation of the kernel module. Execution of the cp command to create a shadow file backup. Addition of the user account Alice to the sudoers group. Modification of the backup user account by root, insertion of the malicious _mod.k module, and successful SSH authentication by the root user. And we can see each of those happening right here. Based on the surrounding events, including the execution of the cp command to create a shadow file backup, the addition of the user account Alice to the sudoers group, the modification of the backup user account by root, and the successful SSH authentication by the root user, this activity appears highly unusual. The sequence suggests potential privilege escalation and persistence behavior, indicating that the event may not be part of normal system operations and warrants further investigation. Now that we have discussed the methodology for determining and reviewing alerts, let's help Mixkitty complete the assessment by examining the remaining alerts and answering the questions below. So what is the name of the module, the kernel module installed on web server 01? So we'll copy the name of server. We will change the name of the host to that. Let's run it. And we want to search for anything that looks like kernel being installed. So maybe this one. That is malicious _mod.ko. Paste that into here. That failed to copy, so let's manually type it out. So malicious mod.ko. What is the unusual command executed within web server by the ops user? So by the ops user, here's ops, and see, okay, the ran bin bash, all of this, copy that value. Doesn't seem to like properly being copied. If I just copy it, Control C, Control V, I think I need to clean this up a bit by removing the actual slashes. So let's see, be 100.22. Oh, we need to remove the dots as well from here. .22 slash 4444 space 0. Those symbols. Let's check that. That's correct. What is the source IP of the first successful SSH into storage? So we'll change our host to storage. Run that command, query, and search for assume SSH connection. Actually, just notice right here, accepted passwords for root from IP. Just paste that in and check. Yep. What is external source IP that successfully logged in as root to app 001? So switch the host back to that. The query, we're looking for external IP that successfully logged in as root, and we can see here accepted password from root. I think that would be this one. Yeah, it looks like that one. Check, that was correct. And aside from the backup user, what is the name of the user added to the sudoers group inside app01? Okay, we're still in app01, so there's backup user, then there's deploy right there. So type that in and check. That was correct, and that is day 10 of Advent Cyber 2025 complete. Like this video, make sure to like and subscribe.